thing that we're going to be doing in this chapter, now that we've learned how to balance equations, is that we're going to deal with different types of reactions. Now we're going to deal with two of them to begin with because they are exactly the same, only opposite to each other. So if you know one, you figure out the other. Of course, we'll do examples of that. But let's take up the most common substance on the face of the earth, water. How is water created? How did it get there? Well, a lot of chemical reactions will produce water as a byproduct, but the creation of water in the oceans and lakes, rivers, whatever, they came about as a result of hydrogen and oxygen molecules or atoms colliding with each other. In the creation of the universe, there are various elements starting with hydrogen and helium. Hydrogen created helium. Helium went through nuclear reactions to create lithium and other things, and beryllium. And then it kept getting bigger and bigger and bigger, and oxygen was later on down the road. Now, hydrogen was already there, so the hydrogen and the oxygen that was created 3.5 billion years ago became the water that we have and other planets have had, and a lot of rocks have in space. There's a tremendous amount of water being trapped in meteors and comets and all that sort of material because of the creation of these elements, and then they were shot out into space and captured or still moving around freely. So what we are going to do, rather than get into the whole astronomical part of it, we're just going to deal with the creation, or what we call the synthesis or the formation of various compounds. Now there's certain rules involved in that you're going to have to follow. So make sure that you follow the script and understand here, as well as what I do on the board. So the two elements we said were hydrogen and oxygen. And so we write that like this. H and O, and they are going to collide with each other. In order for a reaction to take place, a collision must occur, forcing the electrons to create bonds that we talked about in the last two chapters. This arrow right here is what we call the yields arrow. This is telling us that these things here that are colliding with each other that we call reactants are going to produce something. In this case, it's going to produce water. Now the little tubies, you have two atoms of hydrogen for every one atom of oxygen to create one molecule of water. Because this is being produced, we call these, anything on the right-hand side, the products. Okay? Now, there's a number of things that we have to do in order to create a true working chemical equation. Now, the equation word is being used because yields is considered the equal sign like in an algebra problem. Now remember, when we balanced equations, that equal sign meant the number of atoms of each element must be the same on both sides. We'll come back to that. Before we do that, we need to identify the phase at which these elements are found. Now, the thing about our elements is that virtually all of these are metals. I mean, not metals, but solids. Most of them are metals, but there are some solids that are not metals, like sulfur and phosphorus, arsenic, selenium. Those are examples of solids that are not metals. They lie on the right-hand side of that staircase. But everything over here are all metals, but they're in solid form, with the exception, of course, of mercury. So, we'll put all solids, and when we say solids, we represent that up there with an S in parentheses, except, now there are a few exceptions on here. Now, we're never going to see a noble gas in these reactions because they don't react. They have 8 valence electrons in their outermost level. They don't want any more, they aren't going to do anything. So we're going to ignore the noble gases. But what we are going to look at is everything else that could potentially not be a solid. And in this case, if we want to look at gases, now this is gases when they are by themselves, not when they're combined with something else. So we start over here, hydrogen is a gas. Then we jump all the way across over here. The next gas is nitrogen, then oxygen, then fluorine, and chlorine. So beyond the noble gases, there are only 5 gases that actually react. Okay? And we're talking about elements. We're not talking about compounds. We'll do that in just a little bit. The liquids at room temperature. Now we're talking about room temperature. Some of these are really close to turning liquid, but they don't. Example, gallium. If you held gallium in your hand, which is higher than room temperature is right around 70 to 75 degrees. You put your hands around, your body temperature is 98.6 degrees. That's hot enough to melt gallium. So you could have a liquid gallium in your hand, and it won't be hot because you didn't have to boil it with a flame. It just your body temperature did. Anyway, so we don't consider gallium a liquid. We consider gallium a solid, so it fits this category here. But there are 2 liquids at room temperature, and they are bromine and mercury. So when we get up here, we have to identify these phases. So we know hydrogen is one of the gases here. So we'll put a parenthesis and then a G after that. And oxygen is also a gas. Now let's talk about compounds, because we've now dealt with 2 chapters of different types of compound. One was ionic and one was covalent. All right? Now, in ionic compounds, I gave you 2 physical properties for ionic compounds. The first one is they're solids at room temperature. So if it's an ionic compound, it's solid. So the question you have to ask yourself is, what is an ionic compound? How is it different from a covalent compound? Well, we've talked about it a bit in these 2 sections dealing with ionic compounds and covalent compounds. But the biggest difference is that ionic compounds have a metal. And they form crystal lattices. That's another one. Crystal lattices, you've got to have a solid in order for that to happen. So these are all solids. So let's look at the compound we have up here. H2O. Is there a solid in there? Hydrogen is not a solid, or is not a metal. Oxygen is not a metal. So this is not an ionic compound. So your other choice for this is a covalent compound. Now, to be honest with you, they can be any phase. It depends upon temperature and all that, and also depends upon the number of particles involved in it. There's a lot of issues, but we can safely say that they are usually gas, but not all. And so you go, well, how would I know? Well, one thing is, I will tell you for sure if there is any concern about whether it's a solid, liquid, or gas. But say like in this one right here, you know the phase for that? I certainly hope so. It's a liquid. Now, I put that down, but I will tell you, most of the time, especially this reaction right here, when this reaction takes place, there's so much heat involved in it, that actually comes out as a gas. But when it cools down into a liquid. So if you put either gas or liquid down for water, you would be correct. It comes out as steam, but then it cools down and vaporizes into water, liquid. Okay? So, that's how you determine your phases. And we'll do a couple of examples as we go through, but this is one example right here. But we're not done. So now, that's just the first thing we have to check. We have to check for phase.